Ladies and gentlemen, my name is Dr. Theodore Holtom. My company is Wind Farm Analytics, which is an independent wind energy consultancy offering wind turbine power performance analysis, wind energy storage studies, and LiDAR studies. In particular, LiDAR technology development. So, Wind Farm Analytics seeks to commercialize a capable new LiDAR sensor system for wind turbines. What is LiDAR? LiDAR is a laser method for measuring the incoming wind, in this case ahead of wind turbines. The problem is that existing wind turbines measure wind direction and wind speed using a single point instrument. This is typically mounted at the tail of the nacelle housing. So the nacelle is the bullet-shaped housing that you can see in the picture on the top right. And you may be able to make out a little tail on this nacelle at the rear, and this is where the traditional instrument is mounted. This does not account for large wind variation, which is possible across the rotor, as depicted by the red arrows. And of course, wind turbines are getting ever bigger. You can see a picture there at the bottom which shows the blade of a Vestas 164 metre diameter 8 megawatt turbine, and this blade, 80 metres long, is longer than 9 London buses in a row. Well, it would be better to map the variation of the wind field across the whole rotor, and this means measurement at multiple locations, and better still in front of the wind turbine. Because, as you may appreciate, mounting the wind measurement instrument at the rear of the nacelle is not the ideal location for measuring wind in front of this rotating rotor. The rotor extracts energy and power from the wind, and therefore the wind speed behind it is less than in front of it. And also there are streamline effects around the shape of the turbine, and also introduce turbulence from the rotor. Well, what's the solution? And indeed, a unique selling point here is the idea of converging beam geometry. So this is a sort of triangulation idea where you intersect beams at a point as a measurement point in space. And indeed, the beams should be scanning and steerable, so that you can steer them to multiple points in space in front of the wind turbine. I should say there is some existing LiDAR competition, but these instruments use diverging beams. So this is essentially measuring components vastly separated in space in different directions in order to build up a three-dimensional wind velocity vector. This is essentially averaging over a huge area, which is a false or applying a false assumption of parallel flow across the whole rotor. We know this is wrong. This new LiDAR design provides many benefits, including improved wind harvesting. It enables adaptive look-ahead control. You can account for non-horizontal flow, whereas current systems assume a horizontal wind speed. This is not true in many cases. But we can measure direction across the whole rotor, so we can turn the wind turbine more optimally into the wind and thereby harvest more energy. This method can allow for cheaper wind turbine design and identify damaging wind signatures before they hit the rotor. This enables more advanced alarm systems and protection systems in order to reduce the lifetime O&M costs and indeed extend the lifetime of wind turbine components, and allows improved performance monitoring. Myself, I'm a physics graduate from the University of Manchester. I got a PhD in physics also from the University of Liverpool. I was senior scientist for agencies of the Ministry of Defence until 2006, when I joined the wind industry as an analyst. I was focusing on operational wind turbine power performance for many years, and still do. From my work, I observed that we can do better. While wind turbines do work very well already, we can do significantly better. So I've observed significant power performance loss, which we can address. And I also pioneered the use of LiDAR methods for power performance analysis, I can say. I'm working here with the Fraunhofer UK Research Limited. These are laser experts based in this building, in fact, since recently. And also Sker Energy Limited, another Glasgow-based but global renewable energy engineering consultancy, and one of the few companies offering a LiDAR product, a LiDAR sensing product to the wind industry. We also have a fourth partner who is a major global engineering manufacturer. So far, I have filed the UK patent in June 2013 and completed on time and within budget a £133,000 technology strategy board funded feasibility study. We are now working on a £1.9 million TSB funded industrial research project for constructing a field demonstrator, testing and validation, including environmental testing for harsh offshore wind regime. My ask is, in case of a UK patent granted, because it's not yet granted, but I'm hopeful that this will be granted in the coming few months, in that case, then I seek £300,000 investment, which is primarily aimed at international patent filings. Wind industry is big in many countries around the world: China, India, USA, and Europe, and Brazil, etc. And other business development activities towards commercialization. The market size is very large. Global Wind Energy Council indicates, if we assume 8 megawatt turbines, then approximately 8,000 turbines per year for 30 years from 2020. It's a growing market, it's an established market, and it has a good future. Existing LiDARs, 120k, we anticipate perhaps 10k profit, and this is a large opportunity. So thank you for your time, and I'd be glad to speak to you further. Thank you.